All right, this is Chapter 3, Section 4, called Direct Variation. This is for Integrated Math 1, or IM1. So just as always, I'll start this off the same way I do with the other ones. This is the same screen you will see when you log in as a student, with the exception of a couple of things. You will see a due date on your screen on the teacher preview. It doesn't show me that part. You will always see attempts here. So I'm on one of unlimited attempts. You always have unlimited attempts for our system, which means you can submit your assignment as many times as you would like, and you come back in and try again. This particular assignment has 5 questions. They should be anywhere from 1 to 10 questions. We tried to cap it at 10 there. And then grading policy is best score, so whichever attempt is the best one is the one you get to keep. The partial credit is enabled, so if you answer 1 of 5 questions, you get credit for your 1 question. Down here it says, once you start your homework, you must finish it before you can do anything else. And what that means is if I click Start on this very next screen here, on your student screen, you don't see it on my teacher screen, but on your student screen, you will see Submit Assignment down in the bottom right corner. No matter what, when you are done and you want to leave this screen, even if you have only answered 1 question, you click Submit Assignment. That way we can see what you've been doing, we can see the percentage you have so far, and you can just come back in and you try it again on a second attempt. It does not take any problems away that you already have correct. So if you have the first one correct, when you come back in, you do not have to do number 1 again. You can just move to number 2. So it's just keep in mind, always, always, always click that Submit button. It will also lock you out of every other assignment if you don't click the Submit button. So that's another big reason we want to click that one. On the side here, you will see the 3 tools. We always have explanation open, but this will explain the exact problem you are looking at. So you're going to lose your attempt on it. It's going to give you a red X on it because it's going to give you the solution and actually show you the answer. So it's not then going to let you come back and type in the answer or graph the line here. You can click on an example, which just opens up this pop-up screen. It shows you exactly what to do. So create a table here, which is exactly what we're going to do. This is the same method I use. And then we'll graph the line here. You close that little pop-up window. You can click it again for another example if you would like. And then down here is the message center. You can message directly to your teacher from this problem, and then we know exactly where it is you need help, because it will attach this problem. All right, let's go ahead and get started here. So just as I was saying when we looked at an example here, when we're given an equation of a line, for right now, in the future we're actually going to learn another method, but for right now, the first thing you should do is create a function table. So just like this, x, y, and then in the middle, this is where you want it to say y equals and then have an expression with x in it. And you're just going to put the expression in here. You could put y equals 3x if you want, but we just want to work out this expression each time. And you get to pick at least 2 coordinates for x. Doesn't matter what you pick, anything will give you some kind of solution. The one thing you do want to be careful about on here is that you're limited by the screen. So on here for x, I couldn't pick anything bigger than 10 because it would be off the graph. And Alex won't move that graph for me so that it'll fit. So you have to make sure you're picking numbers that will fit within the graph area. So just be careful about that. I can't go more than 10. I can't go less than negative 10. Same thing for y. I can't be more than 10 and I can't be less than negative 10 because I'm limited by the screen. Again, it could be the correct answer. You just can't graph it. So I tend to pick small numbers like this. And I know I said at least 2 points because 2 points make a line. If I want to get from point A, I'll do it over here. Sorry, I can't draw that screen. Point A to point B, well, that would be a straight line, right? The shortest distance between any 2 points is a straight line. Hopefully you've heard something along those lines before. So we only need 2 points to make a line. Well, a third point just lets us make sure that they are, in fact, in a line. So we didn't kind of mess up any of our math there. So that's why I'm asking for 3 points, just because it's a good way to check it real quick. So in here, I'm going to go like this. And I'm going to make these blue, why not? Just so they're a different color. And we have 3 times x. And I'm just going to go ahead and fill this out like this. So I'm going to use this same expression 3 times. But for each one, I'm going to plug in a different number. So this first one, I chose 0. For the second one, I chose 1. For the third one, I chose 2. So I'm just kind of pre-filling these out, and then I'm going to go across and say, okay, if x is 0, and here it's filled in, 3 times 0 is 0. If I choose 1 for x, 3 times 1 is 3. If I choose 2 for x, because we have it plugged in here, 3 times 2 is 6. So I can choose any number I want. Like I said, I've even said it before in videos. You can choose 1,000,000 and plug it in and see what you get for y. The problem is I can't graph 1,000,000 on this chart. So we have to be careful about the size numbers we choose. All right, so remember x is left or right. So my first coordinate here is 0, 0. So if it's 0, I'm not going to go right or left. And if y is 0, I'm not going to go up or down. I'm just going to go right there in the center. So if I go back to the center here, the next coordinate is 1, 3. So it's a positive 1. I go right 1. And then it's a positive 3, so I go up 3. Remember, it's right or left, up or down. And then we have positive is to the right, negative is to the left, positive is up, negative is down. All right, and then if I do that last one there, I have 2, positive 2, 1, 2, 3, 4, 5, 6. And I put a dot there. And those look kind of nicely in a line already. So now I can go click, click, and it's going to snap that line, and I can see they are all nicely on top of that line. So we did that perfectly. All right, and again, you don't necessarily need the 3 points. It's just a very convenient way to check your solution real quick to make sure. And it could either be a problem with the math operation you did on this side, or it could very well be a plotting issue, meaning you didn't plot your coordinate correctly. So make sure you go back and kind of check that if you do end up getting it wrong. I need to make that eraser bigger, dang it. That's just going to take too dang long. There we go. That's better. Okay. So with this one, it says for each table, so they're giving us a table, determine whether it shows a direct variation. If it does, write its direct variation equation. So in order to have a direct variation, we need to see that there's a consistent change in y over x, meaning I need a ratio that's the same. So I want to compare my y over my x for each coordinate here. So for this first one, it's 6 and 2. So I have 6 and 2, and I specifically put y over x. Always do it that way. Rise over run. Think of it that way. Because this actually, we are going to connect this directly to slope pretty soon here. But this is kind of the beginning part of that. So 6 divided by 2, well, that gets me 3. It's 3 over 1, but it can be reduced to 3. The next one is 12 and 4. 12 and 4. Well, 12 divided by 4 is 3. Those look the same so far. Don't stop yet. Make sure you check that third one. 32 divided by 8. This wouldn't get me 3. This would actually get me 4, right? 32 divided by 8 is 4. So this is not the same. This guy doesn't fit, which means this is not a direct variation. All the ratios have to be the same. So let's take a look at the second one here. We have 1 and 4. 1 and 4. And I'm going to turn it into a decimal because what I see here, it's really quick. I'm going to grab my calculator. Oh, they have a calculator open there. I just noticed that. Sometimes they have it open and sometimes they don't. So I'm going to say 1 divided by 4. If you don't know what that is, that's okay. You just use a calculator here. So 0.25. The next one is 1.25 for y and 5 for x. So 1.25 over 5, or divided by 5. 1.25 divided by 5. All right, so we're matching so far. Again, don't stop. We need to make sure that all three are matching. So I had 2.25 and 9. 2.25 divided by 9. Whoops, I wrote 22. 2.25 divided by 9. I accidentally grabbed too many 2's there. All right, look at that. We do, in fact, have the same ratio here, or the same number. So in this case, they're actually all being divided by 4. We can think of it that way. But you can also say they're being multiplied by 0.25. So we would say it is a direct variation. And the way you write this is y, I'm going to scooch that down a little bit. It's y varies directly with x. So with y, we just write y, and I'm going to grab my eraser here just so that this stuff gets out of my way. We just need to remember that 0.25 because we're going to come back to that in just a second. So y varies directly with means equals k, and this is a constant. And what that means is it's the constant we're multiplying everything by, which we just found. And then x, same thing, is just x. So y varies directly with x. We say y equals k times x. I like to also do this as this varies directly with that. We'll practice that a little bit more when we go into some word problems. For whatever reason, it makes me a little easier to explain breaking the pieces down when I say it that way. So we know that this constant was 0.25. We just figured that out. That was the constant variation, right? The ratio. So we can say y equals 0.25 times x. And that is our equation. So y equals 0.25. If you don't put the 0 on here, I believe it might actually let you do it, but it's going to give us grief. Let's check it real quick. So marked it correct. It actually didn't give me any grief about it. It should have. There should be a 0 in front of there. And I've seen other topics or other homework assignments where it does give me grief about that proper way to write that with the 0 on the front. All right. I'm going to switch this up to blue for whatever reason because I like my blue better. Okay, so suppose that y varies directly with x. Ooh, we just learned that. Y varies directly with x, which means times. So we have our equation here. And then they tell us that y equals 15 and x equals 24. Okay, well I have y and I have x. What they want me to find is k. They want to know what that constant of variation is, what that ratio between y over x is. So if I plug my numbers in, instead of y, I'm going to have 15. K I don't know yet, that's what I'm looking for, but I do know x. X is 24. So now I just simply solve for k. I'm multiplying by 24, so I do the opposite. I'm going to divide by 24. So now, and see, they took the calculator away again. So they may very well want us to deal with a fraction here. So with 15 over 24, we don't want to leave it 15 over 24 because these can both divide by at least 3, right? So I get 5 over 8 equals k. So there's my constant of variation. Now I can plug that in here. And when I write an equation for this, y and x are going to stay y and x. Those are ones we start manipulating when we want to know specific coordinates. But we do leave them just y and then equals instead of k. I know that that's 5/8. That's what I was looking for. And then x. Okay, the second part, this is where we're looking for a specific coordinate. So now it says find y when x equals 3. Okay, well I know my equation is y equals 5/8 times x. Well, if x is now 3, what I'm doing is I'm plugging this in and saying, okay, well, if x is 3, what is y on this line? So I'm going to go ahead and multiply. 5 times 3 is 15 over 8, and there's really nothing I can reduce there, so they should be perfectly fine with me doing 15/8 like that. Perfect. They may also accept a mixed number, although since they don't have the mixed number piece here, I'm not sure that they would. It doesn't say there's the alternative answer, but it also doesn't say there isn't one. So it kind of just depends. You can always test those things out since you have multiple chances to submit your answer before it kind of takes it away from you. Okay, so this says, and let's see, I'm going to make this screen just a little bigger so we can, oh, why won't it? There we go. For a moving object, the force acting on the object varies directly with the object's acceleration. When a force of 50 newtons acts on a certain object, the acceleration of the object is 5 meters per second squared. If the force is changed to 90 newtons, what will be the acceleration of the object? All right, so this is where I like, instead of saying y varies directly with x, I kind of like to change it to this varies directly with that. Kind of makes it a little easier for me to work it out. because if I think of what are they giving me first, that's the this. So this would be the force acting on an object. So I'm just going to write force, just to kind of shorten that. We still have varies directly. Varies directly with, but instead of that, I'm just going to say, well, what is that? It varies directly with acceleration. Acceleration. So now I can kind of break this down and go, well, okay, instead of F, I'm going to say, or instead of force, I'm going to say F. Varies directly with, that's my equals K. And acceleration, I can turn that into an A. And I just chose F and A on these two just so that I have a little equation to use. So again, this is just my silly way of breaking down. Instead of worrying about X and Y, I can say this varies directly with that. Whatever you have first is this. Whatever you have second is that. All right. So now let's go ahead and look at what they gave us. So they say a force of 50 newtons acts on an object. Okay, well, I know that the force is 50 newtons. The acceleration of the object is 5 meters. And I'm actually not going to put the newtons on there. I just realized that. I'm going to leave those off. When we get to the end, we'll put the unit back on, just because that'll get a little confusing, I think, having all the units on there. And then after it says that the acceleration is 5 meters per second squared, then it says if the force is changed to 90 newtons. Well, I need to know what this K is. I haven't been told what my constant is. What's the variation? What is it being multiplied or divided by? So we have our equation now. We filled in F and A. We need to figure out what is K. So I'm just going to solve for K really quick. So 50 divided by 5 is 10. K, and 5 divided by 5 is 1. So my constant is K. So the equation that I would write for this would be F equals 10 times A. And I don't really have to put a little dot there. I can just do 10A. So here's my equation. If they had asked me for an equation, this is what they would want us to type in, something along these lines. But what they want us to do is find the next piece here. If the force is changed to 90 newtons, what will the acceleration be? So now the force is changed to 90 newtons, and we want to know what is A. All right, well, I'm going to solve again for A. So I solved for K on this one. I'm just going to solve for A on this one. 90 divided by 10 is 9. 10 divided by 10 is 1, and that equals A. So if the force is 90 newtons, then the acceleration is 9 meters per second. If the force is 50 newtons, the acceleration is 5 meters per second. So I can see that's changing. I had 50 and 5. I have 90 and 9. So I can actually see that pattern of 10 there pretty quick. All right, so I'm going to go 9. It already has meters per second squared, so I don't have to worry about that part. All right, let's do the last guy here. And move to the next section. Okay, so Carmen is riding her bike. The number of revolutions or turns her wheel makes vary directly with the distance she travels. Ooh, okay, so we can do this varies directly with that again. So the number of revolutions, so we have number of revolutions. And remember, that just means it's going around. How many turns does your wheel make? Varies directly, and I'm going to be a little lazy here because of space. So instead of saying varies directly, I'm going to write equals K with distance. And hopefully that makes sense. We can hopefully picture Carmen on a bike. And I'm not very good at drawing a bike here, but we'll pretend like I can draw a bike with a little person on it. Ooh, that's pretty bad. Where are my handlebars? There are my handlebars. And we have Miss Carmen here riding the bike. And the wheels are turning this way, right? So we can see the wheels are turning. And she's moving forward. So every turn would help her move farther forward, right? So that makes sense. That's definitely kind of easy to picture. Not maybe if you look at my stick figure picture, but something along those lines. We have a person on a bike. We can picture the wheels turning, and as the wheels turn, it's going to pull the bike forward, right? That's the whole point of the bike. So we're going to see the graph below now, and we can see the number of revolutions are on the side here, the y-axis, and the distance traveled in feet is on the bottom here, the x-axis. And I can see that this is a positive relationship. the more revolutions. So as this is going up, I have more revolutions, and I have distance is also going up. They're going up in a positive fashion, or positive pattern there. So how far does Carmen travel per revolution? All right, well, we want to know how many feet are in each one. So I'm going to go over here to where I can see it's crossing. I don't want to do 0, 0 because that's at the beginning. So this would mean that she hasn't traveled any distance, and she hasn't, the wheels haven't made any revolution. So I don't want to use this one. I want to use the next point that I can see. And the next one I can see is 10 feet and 2 revolutions, like this, which we can write as a coordinate, to 10, 2. Well, I want to know what is the ratio of y over x. So y over, oops, and I wrote it backwards, y over x, like this. Well, 2 divided by 10, we don't want to turn it into a decimal necessarily. What we want to do is reduce. I can divide by 2 for both of these. That's how I can reduce this, like that. So 2 divided by 2 is 1, 10 divided by 2 is 5. So there's my ratio. I can see for every revolution I make, because that's the top, here's the y, the revolution, how far do I go? I go 5 feet, because that's my x. So I just answered that question by using my ratio. And then the next one they're going to ask me is, what is the slope of the graph? So the slope is not 5, it's the 1/5. Slope has to do with the steepness of the graph. How quickly are we rising? So with this one, I'm rising 2 revolutions and I run 10 feet. I rise 2 revolutions again and I run 10 more feet. So every 2 revolutions brings me forward 10 more feet, or every 1 revolution brings me forward 5 feet if I reduce that. All right, let's go ahead and check that guy and we should be good to go. All right, that was section 4, and I will see you in section 5.